Welcome to another interactive video on the chapter I made called Report Constellations. The idea of this chapter is to give you a background story to the common investigations you send for patients on a regular basis. This video contains my ideas and probabilities, so don't consider this a reference channel. My topic now is alkaline phosphatase. Let's split the words. Alkaline meaning high pH and phosphatase meaning enzymes removing phosphate ions from larger molecules or dephosphorylators. All you will be wanting to know as a medical professional is this list. If you are interested in further thought on ALP, let's keep talking. The normal level of ALP is 44 to 147 international units per liter. Let's look at the list again. Alkaline phosphatase is increased in inflammatory conditions, bone growth, certain tumors, and gut related conditions. Importantly, pregnancy where there is bone growth again. Alkaline phosphatase is a dephosphorylating enzyme. It removes phosphate groups from larger molecules. It is a protein of molecular weight 86,000 Daltons. For example, if we give it a molecule of adenosine diphosphate, the enzyme will catch hold of it and remove its phosphate group with its zinc ions to give adenosine monophosphate. If we give adenosine monophosphate, it may give us adenosine alone. Alkaline phosphatase is present throughout the body, so are molecules containing phosphates such as nucleosides. It is present also in E. coli, which may have received the enzyme from enterocytes. It is also present bound to the cell membrane of cells. Polar molecules which have a phosphate group can enter into the cell membranes by alkaline phosphatase, which removes the phosphate group. Secretion of alkaline phosphatase is genetics beyond the scope of this video. As we know, alkaline phosphatase works in alkaline pH, which is in bones, hepatobiliary apparatus, and placenta. Now I have two hypotheses to propose. One, I call it relative alkalinity, and two, the normal negative feedback mechanism. These are two things that I made up. In the body, there is acidity, buffers, and alkalinity. When one organ secretes more hydrogen ions, the rest of the body may get deprived of hydrogen ions in spite of the buffers and become alkaline due to an exhaustion of hydrogen ions or due to an exhaustion of enzymes such as carbonic anhydrase. This could be an explanation to the rise in ALP in acidic states such as gastritis and inflammation. Another hypothesis is that action of ALP decreases at lower pH, thus the body produces more ALP to combat it. In conditions such as hepatobiliary obstruction, the alkaline bile which has to reach the duodenum stays in the bile ducts. The rise of ALP here may be due to alkalinity in the liver or due to acidity in the duodenum due to my hypothesis. The actual reason for rise in ALP in any condition is still under research. In bone, it may contribute to mineralization by cutting out phosphate groups from complex molecules. The placenta in pregnancy produces a lot of ALP for bone growth of the fetus. ALP also gets secreted when there is a decreased phosphate level in the body. ALP is not the only phosphate group removing enzyme. So it is interesting that exercise causes increased ALP if bone growth occurs. But breakdown from ATP to ADP in muscle movement may not be due to ALP because of the presence of acetic acid and lactic acid, causing low pH. ALP can be both a cause and a biomarker for inflammation. Because free phosphate in high levels cause systemic inflammation and renal damage. But the stimulus for increased ALP may be phosphate containing inflammatory agents or cell mediators. ALP is also raised in certain cancers which are also inflammatory states. Thus, increased ALP beyond normal range is certainly bad. Now we can manipulate ALP to use. One is for dephosphorylating various compounds. We can use ALP on cell membrane. For example, if ALP is on E. coli cells in the intestine, phosphate containing biologically inert compounds can reach the intestine and dephosphorylate to reach the cytosol of the bacterial cell. Thus, it can be used as a cutting receptor in any cell containing ALP on its membrane. Now, I have another hypothesis on using this as a complex drug target for burns because ALP can withstand up to 90 degrees Celsius. We can phosphorylate steroids, painkillers, and anabolic compounds. ALP would be present in inflamed tissues which are burnt, thus, medication can reach the inside of the cells directly if ALP is secreted in the burnt tissue inflammation. Thanks for watching. Like, share, and subscribe. Click the bell icon.